a flattened circle. It's a really good thing to be talking about at Easter time because it's kind of egg-shaped. That's what an ellipse is. Now, they are very, very easy to handle. So pay attention. I don't think you did ellipses last year. So pay attention. They're very, very easy. If this had been a circle, so if we didn't have this stuff on here, where would the center of that circle be? Now notice there hasn't been anything added or subtracted. There's no parentheses. So where would the center be? At the origin. If there is nothing added or subtracted, if you don't have parentheses like this, if you have just an x squared, it's at the origin, okay? So you have a center at the origin. I'm going to make a list over here. I have to find the center, the vertices, the foci, the major axis, and the minor axis. That's the information I have to find. This is going to be easy, though. You're going to enjoy this. All right, so the center is at the origin. Do you see this 9 right here? It is under x. X is this axis, right? So that number, the fact that it's a 9, tells me that my x radius is 3. Now, before you say, oh my gosh, I'm confused by that, I want you to think about this for a minute. If this were a circle, and it said x squared plus y squared equals 9, what would the radius of that be? 3. You take the square root of it, right? So we take the square root of these numbers, just like you do the radius. Only, we have 2 different radius numbers. Under the x, our radius number is 9. So we count forward and backward 3. Under the y, our radius number is 4, which means we're going to go up and down 2. Do you see how we get kind of the oval shape then? Because we're going different amounts this way than we are this way. When we join the dots, we don't get a perfect circle, we get an oval, we get an ellipse. This is called an ellipse. These 4 points that I just connected are called the vertices. So my center was at the origin, and I have 4 vertices. Negative 3, 0, positive 3, 0, 0, 2, and 0, negative 2. Now again, how did I get these vertices? I started at my center, and what did I do? Well, I went sideways, the square root of that number, and I went up and down the square root of that number. And that's how you do it every time, starting at your center. Now, every ellipse has what's called a major axis and a minor axis. What do you think the difference is? What do you think makes something major and something else minor? What's the difference? The greatest one, the longest one is the major one. So how long is my major axis? 6. That goes here. It's 6 long. Why is it 6 long? Because you went 3 this way and 3 this way. Now how long is your minor axis? 4. Now do you think it's possible for the major axis to be the long one this way? Do you think it's possible for it to be stretched this way? Yeah. If the bigger number were under here, right? Okay. Now, your focus points, remember in our parabola we had a focus? Now we have 2 of them. They're called foci. The foci, those are the, that's plural. Anybody here like take Latin? You know, that's plural for focus. And they are always located on the major axis. So they are somewhere. I have no idea where. I'm going to figure that out. but they're always on the major axis. Okay? Now, again, even if you don't know anything, you can get half credit, because tell me what you know about these 2 points. What do you know about the coordinates of these 2 points? Do you know either one of these numbers?
0.
You know y is 0, right? So you're going to get half credit without knowing anything, because you know those have to be 0 because of where they are. Now the distance from the center to the focus. In a parabola, we call that P, vertex to focus, we call that P. In an ellipse that doesn't really have a name, we just say this distance right here, from the center to the focus, in this problem, is the square root of 5. How did I do that? How did I get the square root of 5? What did I do to get that distance? Emily?
Isn't it like the spaces inside the oval?
Well, definitely they're inside the oval. Look at your equation. How did I get that? What did I do down there? What did I do? I subtracted my denominators and took the square root. That's exactly right. So you're going to have to remember that piece. You just got to remember that. To get the distance from here to here, we're going to subtract our denominators and take the square root. So I'm going to start here and go forward root 5 and go backward root 5. So those are my focus points. Root 5, 0, and negative root 5, 0. So part of the ellipse is super simple. Part of it is a little harder because you got to remember, but oh well, but we just have to do it. You ready to try a little harder one? Now, I will always have these in standard form for you, so you don't have to worry about doing anything to the equation. The equation's already set up. And again, graph paper can be useful, for some of you especially. Graph paper can really come in handy. All right, anybody want to take a wild guess where my center is? At 1, negative 2. Just like with a circle, kids. Everybody see it? 1, negative 2. Your center is at 1, negative 2. Right there. Now, nobody's going to grade your picture. You don't even need to draw one. I do. I can't do the problem without a picture. But I'm not grading the picture. I'm grading this over here. Where's the center? 1, negative 2. Everybody okay with that? Austin, you okay with that? Now, I'm going to go ahead and find my vertices. So I need to start here at my center, and I need to count sideways, and I need to count up and down. Take a look at your equation. How many sideways do you think you're going to be counting? 4. So I'm going to start at this point right here now. It's not the origin. I'm starting at my center. And I'm going to go 1, 2, 3, 4. Where will that be if I count forward 4? What point will that be right there? Wait, I'm going forward. So this is 1, negative 2. So this will be 5, negative 2. Now again, what does Miss Ford keep saying? If that is confusing to you, get yourself some graph paper and just count. Now, I went forward 4, now I'm going to come back. 1, 2, 3, 4. Where's this one?
Negative 3, 2.
Negative 3, negative 2. That's exactly right. Negative 3, negative 2. Now, what am I going to do with this? 25 right here. What does that tell me to do? Go up and down 5. So here we go. I'm gonna run out of room down here, but up here we go. 1, 2, 3, 4, 5. Where am I? 1, 3. I like that. 1, 3. And then 1, 2, 3, 4, 5. I'll squeeze it in down there. I went down 5. So 1, -7. Now, I didn't graph this. I ran out of room down there. But can you see it's longer this way this time? Yours is probably a better picture than mine. I ran out of room, so I had to squish it up. But it's stretched this way. All right, these 4 points are your vertices. So you're going to write them down in the blank over here. 1, 3, -3, -2, 5, -2, and 1, -7. Those are my vertices. Those points, when you started at your center and you counted up and down and left and right, connected the dots, those are your vertices. Now, all ellipses have a major and a minor axis. So how long, all you have to do is tell me how long they are. How long is your major axis? 10. Why is it 10? Because you counted up 5 and down 5. How about your minor axis? 8, because you went sideways 4, right? Left and right 4. So it's 8. Now, this is your major axis right here. We know it's up and down because the y number is bigger than the x number. So it's this way. Somewhere on there, and I have no idea where, and I'm not grading your picture, so it doesn't matter, but somewhere on there are the focus points. Okay? Now, tell me what I know about those focus points, even without doing any work at all. Tell me, look at those points right there. What do you know about one of their coordinates? X is 1. The x coordinate is definitely 1. It's right in line with all the rest of them, right? So I have half credit for just paying attention to the picture. Now to get the y, I have to know how high up to go. I have to know what this distance is. So center to focus. Anybody remember how we found that in our first example? We subtract our denominators, and you always take the big one minus the little one. So it's 25 minus 16, the square root of that. So that'll be 3. Right? So you're going to start right here at your center, and you're going to count up 3. All right, now wait, if I count up 3, here's my center. If I count up 1, 2, 3, where am I going to be? At 1, 1. Very good. Now I'm going to count down 3. 1, 2, 3. 1, whoop, 1, -5. So 1, -5, and 1, 1 are my focus points. Got it? It's not too bad. That last part's a little tricky sometimes. All right, you ready to try one with your partner? Say, sure we are, Mrs. Ford, can't wait. All right, so let's try C right now on your own. Compare notes with your neighbor. Remember, this is the information you are trying to find. So see how much of that you can get filled in without my help. Now, I don't want you to be tricked right off the bat. Where's your center? Remember what I said, if there's nothing added or subtracted, it's at 0. So your center is at -3, 0. Do not be tricked. That's your center, -3, 0. Because there's nothing added or subtracted to the y.
Nice very early though.
Was it you?
What?
Saying all that stuff?
I was totally him. With you. I was for sure him. I didn't say anything. I didn't say anything. I don't know why I would. You working to just be rude.
Joseph, come on.
Yeah, so what do you mean?
Has anybody found the vertices yet? You have? There should be 4 of them. So tell me what they are. 0, 0. -6, 0. -3, comma 4. All right, let's pause a moment. What does the rest of you think about that? You think she did okay with that? I think she did perfectly with that.
I did it the other way.
What do you mean?
Like, instead of it being one like that, I did it.
Oh, remember, it's real easy to remember. If the 9 is under the x, that's 3 in the x direction. X is always sideways, remember. I mean, that's the x-axis.
See, because Y is 9.
Oh, yeah. Sorry about that. Yeah, it's a little bit confusing. But in this case, whatever letter it's under is the direction you go. Okay? Yep, Jonathan, you're right. There's a lot to keep straight. Does anyone have a question about those 4 points? When you write them down, they can be in any order. It doesn't matter what order they're in. Everybody get those vertices? All right, how about the major and the minor axis? Did you get blanks for that? 8 and 6. Everybody okay with that? Good on that? Okay. Now, foci. These are the hard ones. That stuff's pretty basic, but this is a little hard. So first of all, we got to remember they're on the major axis. So they're going to be here somewhere. Now I want you to get in the habit, just so you can at least get half credit, of writing down what you know. Now think about that for a second. What do you know about every point on this line?
It's the same distance apart.
X has to be -3. Don't we know our x is -3? So our x coordinate is going to be -3. Now, the distance from the center to the focus, that's what I need to know. I know I'm going to start here at my center and I have to know how far up to go. The distance from the center to the focus is going to be what? √7. That is not a very nice number. That's okay. Start right here and go up √7. Where will you be? If you start here and go up √7, where will you be? At √7. And what if you go down √7? -√7. There you go. There are your foci. Okay, we got one more to go. Be happy. Could be worse. You could be like in a class you don't like.
theology. Oh.
All right. Here we go. We are on Precal time. All right. Let's give this a shot. See how much you can fill in.
Oh. Okay.
Again, this is not meant to be tricky. Where's your center? 0, 2. So that's where we are starting this time, at 0, 2. Okay. So go ahead and find your vertices. Wake up, Roberto.
Sorry.
Quincy, you still have a test to take. Yeah. Remember when you took your 4-week spring break?
4 weeks. Oh, a test.
A quest. You need to get it taken.
When can I?
From your
Well, you do it today after school, you do it tomorrow after school.
See, today after
So I
school.
then I go up one, but then I
Attention.
don't have to. Okay,
Yeah.
first 4 to 5.
Yeah, how about tomorrow after school?
So I go
Yeah.
up 4 to 5.
Don't forget.
or is it the other way around?
Today's Wednesday.
They have two.
Oh, the number is different.
Yeah, up to, and then for the,
Today's Wednesday.
yeah, it's just one.
So,
Square one's one.
Thursday after school, you probably have detention, so
I'll go
maybe you
Thursday
can.
before.
I can't be up late right
I'll
tomorrow.
go Thursday.
Oh, okay.
All
All right, did you get your vertices? Somebody tell me what they are. 4 points. What are they?
Negative 5, 2.
Negative 5, 2.
5, 2.
5, 2. What? 0, 3. 0, 1. What do we think about that? Do we think 1, 2, 3, 4, 5? 1, 2, 3, 4, 5. Up 1. Oh my, this is a really skinny one, isn't it? What do you think about that? Is that okay with everybody? Is that okay with everyone?
Yeah.
No questions about that part?
That will forever be a fun.
How long's your major axis? 10. Minor?
3.
Wait, how long's your minor?
2.
2. You went up 1 and down 1, right?
Okay.
We went up 1 and down 1. That's 2. Is that okay with everybody? 2? See it now? 2? Okay. Now we need our foci. We know that they are located on the, oh, look at that neon marker. Probably doesn't show up the letter, does it? We know that our foci are located on the major axis. So just stop and look at the picture. What do we know about these 2 points? What do we know about them? They're all up 2, right? Their y has to be 2. How far is it from the center to the focus? Square root of 25 minus 1, which is root 24, 2 root 6. So you're going to start right here at the center, and you're going to go forward 2 root 6 and backwards 2 root 6. One a day is right. That's a good deal. Okay, I see you tomorrow, right? Yeah.
I'll give you that state form.
All right, have a great day. Good work today. Hopefully